Hi everyone, my name is Neeraja Rendu. I'm a Principal Product Manager in AWS Redshift. Today we are going to talk about a topic, data sharing, which is a recently added capability in Amazon Redshift to allow you to share live data between Amazon Redshift clusters. Let's dive in. This is our agenda for the session today. First, I will start with what is data sharing, what is the problem we are trying to solve, and give an overview of the capability. Then we'll talk about the use cases for data sharing and finally wrap up with a very quick demo of data sharing and how the end-to-end workflow looks. Amazon Redshift is a fast, scalable, secure, and a fully managed cloud data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL. Redshift offers up to 3x better price performance than any other cloud data warehouse. Tens of thousands of customers use Amazon Redshift to process exabytes of data per day and power their analytic workloads such as high performance, business intelligence, reporting, dashboarding applications, data exploration, and real-time analytics. Many of these customers have what I would say as multi-cluster deployments. So they have many Redshift data warehouses or clusters. And prior to data sharing, if they have to share data between these clusters, they need to manually unload the data and copy the data from one cluster to another. So I'm referring to these as producer cluster and the consumer cluster. So the producer cluster is where you need to copy the data from, and the consumer is where you're copying the data to. These are Redshift clusters. So this manual unloading and copying the data, it can become expensive and cumbersome, especially when you have many consumers to share data with, because you need to build and maintain ETL pipelines to provide relevant subsets of the data to each consumer. There are also security and governance concerns because whenever you're trying to unload the data, then the producer cluster administrator could essentially lose control on who is going to consume the data. So they have to put in manual kind of practices in place in order to ensure compliance usage of the business critical data sets. There are problems on the consumer side too, because you need to reconstruct the data sets that are coming from the producer clusters. You need to manage the schema changes. There are also concerns around stale data because when you're unloading and copying the data manually, you probably are not doing it continuously. It is probably running a few times a day. Therefore, there is concerns on to get stale data and unable to provide real-time insights for the business teams. And there is also concern on incomplete and inconsistent use of the data, which could, again, limit insights for the business teams. So this is really the problem that we are trying to tackle with data sharing. So with Redshift data sharing, essentially now you have a way to securely and easily share live data between Amazon Redshift clusters. And these clusters could be in the same AWS account, or the Redshift clusters could be in different AWS accounts. So data sharing is a capability that we have announced at reInvent 2020 last year. And the ability to share data across clusters within the same account became GA a few months back. And now we also have ability to share data in clusters that are in different AWS accounts, essentially cross-account data sharing. Now we have it in preview. So what exactly is the kind of the benefit of data sharing? The first and most important one is it's simple. It's a very direct way to share data between Redshift clusters. You don't have to manage ETL pipelines. You don't have to copy the data. You don't have to move the data. It's instant. So when the producer cluster administrator determines that they want to share the specific table, the specific view. So whatever the data set that they want to share with their consumers, the consumers get immediate access to the data. There are no delays. And the data sharing, it can be granular. So you can decide whether you want to share an entire schema or an entire table or a view or even user-defined function. So you can control the granularity of data sharing. And the data sharing is also high performance. Another benefit is it's live sharing. So what that means is as and when the data is updated on the producer cluster, the consumer cluster is getting immediate access to the data, and the data is transactionally consistent views. So it's live data that they're able to query. And data sharing also provides secure and governed collaboration. So with data sharing, you are sharing the data within an organization, but you could also be sharing outside the organization and with your external ecosystem like partners and your own customers. So data sharing provides a secure and governed collaboration. And as a producer, you can always have control on the data set. So it's at any point, if you want to revoke permissions on the data set to specific consumers, you can do that, and immediately the consumers lose access to the data. Similarly, there is usage tracking on how the data sets are being used, which data sets are most useful. So there is end-to-end security and governance in place when you leverage data sharing. Data sharing builds on Amazon Redshift RA3 and the managed storage. So RA3 is Redshift's next generation instance types, which allow you to scale and pay for compute and storage independently. So with managed storage, essentially as a customer, you don't have to be limited in terms of how much data that you can store in Redshift to what is available in your local cluster compute nodes. So you can scale beyond the cluster to tens of petabytes of data in a very seamless fashion using the Redshift managed storage. So this is we launched the RA3 in 2019. So we have widely adopted customer base for RA3, which again is our next generation instance types. So data sharing builds on RA3 and the managed storage layer. So what that means is the consumer cluster. So both are Redshift clusters here in this picture, producer cluster and the consumer cluster. When the consumer cluster has some queries that are executing and accessing the shared data, the data is directly queried from the managed storage layer. So the consumer queries are not going and hitting the producer cluster compute nodes and impacting its performance. So workload isolation is a core design element and the benefit of data sharing. So the way to think about it is you have consumer cluster, you're getting queries on consumer cluster, and they leverage the compute from the consumer cluster only. Similarly, you have workloads that are running on producer cluster, they are leveraging compute only on the producer cluster. But from a data access layer, the consumer is able to access the data for read purposes from the producer. So again, the whole data access is happening through the managed storage layer, so there is no impact to the performance, and the workloads accessing shared data are isolated from each other. And the producer and the consumer clusters are regular Redshift clusters. So what that means is the consumer cluster is not only able to read the shared data from the producer, but of course it can also have its own private data. So it can read and write private data to the managed storage layer, but the data it got through the data sharing is for read purposes. From a deployment perspective, the producer pays for the managed storage and the consumers pay for the consumer cluster. So the data sharing as such does not have any cost associated with it. So if you have RA3 clusters, Redshift RA3 clusters, you can start using data sharing immediately. So that there is no extra setup needed and there is no additional cost involved. So what are the different use cases for data sharing? There are many different use cases and many different usage patterns for data sharing. I will try to highlight some of the most common ones. The first one, a very commonly heard one, is workload isolation, where you have a need to support very diverse business critical workloads easily and cost effectively while still meeting the SLA requirements. So workload isolation is a key use case of data sharing. So with data sharing, you can rapidly onboard new analytics workloads. So let's say you are a data warehouse administrator and somebody comes and says, I need to do this ad hoc analysis for our new marketing campaign. You can simply tell them, okay, go and spin up your Redshift cluster. I will share data. So the consumers don't have to worry about where to get the data from, how to ingest it, how to manage it, and create more and more silos. It becomes very easy to support new analytics workloads and especially ad hoc workloads that really don't have a need to manage data. A second aspect of workload isolation is you can size and scale individual workloads according to their performance requirements. So as you see in this picture, the ETL cluster, for example, needs RA316 Excel node types, and it needs 4 node in order to meet the performance requirements. For the dashboarding, on the other hand, these are very small queries, very high concurrent queries, and have strict SLA requirements. So I might want to size it in a different way compared to a data science cluster, which probably is not that performance intensive, but the flexibility of data access is more important. So essentially, you can think of what are the different workloads that we need to support on our data warehouse and pick the right instance type and size them, pick the number of nodes according to their performance requirements. And because each of these is a separate Redshift cluster, one of the important aspects of data sharing is you automatically get chargeback capability. So if you're trying to run a multi-tenant platform where you're supporting all these different workloads on the Redshift environment, you can have different teams have their own cluster. You can track their usage and essentially allow them to pay for the compute they use. So chargeback is an important benefit here. So, one I think important point to remember is the clusters that we are talking about. These are regular Redshift clusters. So let's say you have data science usage only for a few hours in a day, like morning 9 to 12, and after that there isn't much usage that is happening. So these clusters can be paused and resumed just like any other Redshift cluster. So all the capabilities of Redshift, they apply for the clusters that participate in data sharing. The second use case, again, a very common use case is what I would refer as cross-group collaboration. So more and more organizations want to decentralize their data warehouse management. So they don't want to have like this single big data warehouse onto which hundreds of teams come in. Instead, they want a more decentralized environment. Some people refer it as like a satellite kind of a model, satellite clusters. So where they have many clusters, consumer clusters, producer clusters, and they all form this mesh type of an architecture. Though they are separate Redshift clusters, separate Redshift data warehouses, they all have need to share data. And typically the need is because they want to collaborate with other business groups for more broader analytics and data science, or they might be launching some new product and they need to do cross product analysis. And with data sharing, they also don't have to worry about compliance concerns with manually moving the data. And each of these Redshift clusters can be a producer and a consumer of the data. So the sales team, for example, might be sharing some specific data sets with marketing, and marketing can share some data sets with sales. So data sharing is a two-way concept. In addition to workload isolation and cross-group collaboration, another very common use case is delivering data as a service. So this becomes very relevant with cross-account data sharing. So the idea is you are managing the data centrally as an asset, and you are sharing the data with the consumers. They could be in the same organization or they could be separate organizations. your customers, your partners, basically outside the organization. So data sharing makes it very easy to offer data and analytics as a service, again, because you don't have to worry about moving the data. You can securely share live data with all these consumers, consistent views again of the data. And data sharing also provides mechanisms with which you can monitor and track usage and understand whether particular data sets are being useful for your consumers. And you also get to retain the control of the data set. So this is advantage from a data provider perspective. From a data consumer perspective, you don't have to worry about, again, loading the data and copying the data into Redshift clusters. Basically, directly access the data that is available in the provider environment. So it's live sharing that makes it very, very useful and real time. Another very common use case is sharing data between different environments. So you might have development, test, and production environments. Today, prior to data sharing, if you have to share data between these environments, typically take a snapshot, Redshift snapshot of the data at a point in time, and then you would restore it into the other environment. So rather than having to do restore an entire snapshot with the data sharing, you can granularly share the data. So for example, the development team needs to debug an issue that is happening in the production environment. The production cluster can simply share the table or the set of tables that are needed for the development team to reproduce the issues and fix the issues. So basically, it improves the agility of the teams and speeds up the overall product development lifecycle. So we talked about the use cases of data sharing. So let me switch gears and talk a little bit about how data sharing actually works. So data sharing is pretty straightforward. There are two notions. There is a producer cluster, and then there is a consumer cluster. The producer is the one that is sharing data, and the consumer is the one that is receiving the data and querying it. So the basics of data sharing is you're starting the data sharing workflow by creating what is called a data share. So it's a new type of object that we are introducing in Redshift. So it's a database level object. So the data share, you can think of it as unit of sharing. It's a metadata container. So on the producer cluster administrator would start the workflow by creating a data share. And then they add objects to the data share. The objects can be a Redshift schema. You can add a Redshift table. You can add a Redshift view, materialized views, late binding views, user-defined functions. You can add objects from multiple schemas in a database. So essentially, the producer cluster administrator and the people with relevant privileges can add objects at a variety of granularities at which they want to share the data with their consumers. So you create a share, you add objects, and then you add consumers. So a consumer in a data sharing it can be another cluster that is in the same account. So in this picture, there are two accounts, account 1 and account 2. And then we have in the account 1, there are multiple clusters. So the cluster that is sharing the data, which I'm referring as a producer, and there are a couple of other clusters that are acting as consumers. So when you're sharing data, you can add consumers. The consumer can be another cluster in the same account, or it can be a completely different AWS account. And you can add more than one consumer to a specific data share. So that's pretty much are the steps on the producer. Create a share, add objects, add consumers. Again, when you create these data shares, there is no data movement happening. It's strictly a metadata operation. There is no replication or anything involved in this one. It's just configuration. Now on the consumer side, consumer cluster essentially can look at the data shares, list them, see what are the contents of the data share, and decide whether this is an interesting data that they want to consume or not. And the way to consume the data share, again, is pretty straightforward. The consumers just need to create a database, but rather than creating a database from scratch, they create it from the data share. So essentially, they create a reference to the data. Now the consumer cluster users can come in and start querying the data. So the important point is consumer cluster users continue to connect to the databases on the consumer cluster, but now they can query the data that is coming from the other clusters via what we refer as a cross database query. So you connect to one database, but you can query from any other Redshift database, including the ones that are coming as shares from other systems. Similarly, if the data share is also given access to another cluster in the same account, even this consumer can create a database from the share, where we are calling it data share 3 DB. And same thing, if you share with an account, any cluster, whatever the cluster that gets access to can create a database from the data share. When you do cross-account data sharing, that is, you're sharing from one account to another AWS account, there are a few extra steps, because in this case, data can be actually going outside the organization. It's a lot more security sensitive. So the additional workflow is, once you create the data share, the producer account administrator need to come in and authorize the data share, saying, okay, it's okay to share this with this other AWS account. Similarly, on the consumer account administrator need to come in and say, yeah, it looks good to consume the data from this other AWS account. So essentially, there is a handshake involved. So this is IAM-based APIs and permission model. So there is a handshake involved to make sure that this is okay from a security perspective. So that is the additional step for a cross-account data sharing scenario. Other than that specific handshake that I mentioned, everything else is same, whether you are sharing the data within an account or across accounts in terms of data share creation and as well as data share consumption. So one I think very cool thing with the data sharing is you can actually leverage familiar tools. So whatever the BI tools that you're using, you could be using QuickSight, you could be using Tableau, MicroStrategy, ClickView, Spotfire. So your business intelligence tool of choice, your query tool of choice, you can use all these tools with the data sharing. So what that means is the shared data that is coming from other clusters is discoverable through the standard SQL and analytics tools. So we have shipped some additional metadata views as well as modified the JDBC ODBC drivers so that the shared data is visible as part of the standard SQL and analytic tool interfaces. And so from an end user perspective, they're seeing the shared data just like they see local data from their local Redshift clusters. And more important thing is not only they're able to see the data, they can query the shared data, they can actually perform joins between the local data and the shared data. This is where the cross database query functionality becomes interesting, where the consumer cluster users continue to connect to the databases on the consumer cluster, but they use this cross database query notation, like a three-part notation that says database.schema.table. So select star from database.schema.table kind of notation to access the data that is coming from other Redshift clusters. And another very often, I think this question comes up is, what about security? Because from the producer side, I might be having 3,000 columns in my table, I created a view on top of it, and I'm sharing maybe like 10 columns of that table. Or another scenario is I might have thousands of tables, but I have shared only 2 tables as part of my share from the schema. So what about the metadata security? So data sharing respects metadata security. So the consumer clusters see only the relevant subsets of the data. So relevant subset columns, relevant subset of the table. So whatever is added as part of the data share is what they see. They don't have any visibility into the metadata of the objects that are not shared with them. So I think it's worth spending another couple of minutes on the security in data sharing, because with data sharing, you suddenly can open up data very broadly in your organization and even go beyond outside the organization. So security is an important consideration whenever you're thinking about sharing data. And this is a key design element as part of this feature, and we have made sure that both on producer side and consumer side, there are enough mechanisms in place in order to ensure that the data sharing is fully secure. So first of all, on the producer side, you have privileges to control sharing of the data. So you can decide who can create data shares, who can add objects to data shares, who can add consumers to data shares. By default, only administrators, cluster administrators have access to do it. The second aspect is you can share data at desired granularities. You might have thousands of tables, but you want to share only one table. So that is possible with data sharing. And on the producer side, you retain the control on the shared data set. So at any point, if you want to revoke permissions on the data, you can do that. And immediately the data sets are, they disappear from the consumer cluster. So the producer cluster retains control. And you can, there are some, I would say like detailed kind of security capabilities. For example, you can say, I don't want to open my data set to any Redshift cluster that has enabled public IP. So if the Redshift cluster is publicly accessible, the consumer Redshift cluster, the data share should not be queryable. So you can put in additional practices in place like that. Another one, as I mentioned before, is there is a pretty comprehensive authorization and acceptance workflow for cross-account data sharing with this handshake governed by IAM, because again, the data could be going outside the organization. And we also have pretty detailed usage tracking and auditing, both in system tables as well as CloudTrail, on the data sharing. So what kind of objects are being added to the data share? What is being removed? So essentially all the changes that are happening to the data share, and also all the accesses that are coming into the data share, which clusters are accessing it, which accounts are accessing it, which objects they are accessing. So there is a pretty good usage tracking on how the data is being consumed and how the data shares are being evolved. On the consumer side, the consumer cluster administrator has control on who should be given access to the data. So the boundaries for data sharing are cluster and account. So once the producer cluster trusts a consumer cluster and gives them access to the data, it is up to the consumer cluster administrator to decide which users and groups in the consumer cluster that should get access to the data. And if they want, they can create views on top of the shared data set, so they can further restrict access to the shared data. And for cross-account scenario, as part of the handshake that I mentioned, the consumer clusters, consumer accounts can reject data shares. So I got some data share from particular account. It doesn't seem interesting to me. It actually might seem suspicious to me. So I can say, I don't want to access this particular data set. So there is ability to not just accept, but also reject data sets. So with that quick overview as well as drilling a little bit into the use cases, we can walk through a quick demo on how data sharing works end to end. So the scenario I'm trying to show is a simple workflow end to end. So this is a bicycle manufacturing company. Here they have an analytics center of excellence team that is responsible for gathering data from different data sources, ingesting it, processing it, and getting it ready for consumption. So they have a Redshift cluster with which they do they manage data. And then they have many consumers that consume the data. So in this scenario, for simplicity, we are picking one consumer, which is sales ops reporting. So from the Analytics Center of Excellence team cluster, or we call it like central cluster, data is fed to the sales ops reporting cluster every night. So there is a nightly ETL feed that comes in. And if the sales ops team cannot wait for one day and they need more quicker access to the data, manually they raise a ticket and somebody comes into the mix. They spin up an ETL pipeline, they rerun the pipeline to make the data available for the sales ops reporting team in time. So the problem here is sales ops team is constantly worried that they don't get access to live data. Most of the times they don't have visibility into what is happening out there in the field. They don't have real-time metrics. So the concerns are about stale data. And from the analytics COE team, the central data warehouse team, their concern is they have to deal with this complex data movement, creating these ETL pipelines, managing pipelines, and it is costing them time and money, and also introducing delays. And last but not the least, there is the problem of data redundancy, right? The moment you create copies of the data, they can diverge at any point, but you are also creating silos and redundant copies of the data in different clusters. So that is kind of the problem that they're trying to deal with. With the data sharing, this architecture can be simplified significantly. The idea is now the central cluster, COE cluster, can share data live to the sales ops reporting team so that they can get access to live data and get it in a highly performant fashion. And the central team can eliminate the complexity of the data movement, and the sales ops team can get faster access to the data, and they can also trust the data because they're directly getting it from the source of truth. And again, for illustration purpose, we have used the sales ops reporting as one consumer here, but data sharing allows access to as many consumers as you want. For example, from the central cluster, the data could be going to a marketing cluster, a finance cluster, or some data science cluster. So data can be shared to any number of consumers without concerns. Yeah, so let's dive into the demo here. So the demo is, I'm going to talk about the workflows, what happens on the producer, what happens on the consumer, step by step, so we can understand how data sharing works end to end. So the first step in data sharing is creating a data share. So here I'm creating a data share called the sales share. You give it a name, it's a metadata container. Then you add objects to the data share. So you use a command like alter data share, add schema, add table. So as a producer cluster, you can decide what is the granularity at which you want to share the data. You can add an entire schema. You can add specific tables, views, materialized views, etc. Once you add objects, you want to grant usage on the data share to a consumer. So the consumer here is another cluster that is in the same account. We are referring it as a namespace. So it's essentially a cluster. So I'm giving access to another cluster. So I have a set of views on the producer called SVB data share views that allow me to see all the sharings that I have done. So for example, I created an outbound share. I can see the objects within that share, right? So what are all the objects that I have added? And And note the share type. It's an outbound share. That means I created it. It's not a share that I got from somebody else. And there is also SVB data share consumers, where I can see what are all the consumers with which I have shared my data set. And again, a data share can have many consumers. These can be clusters, these can be AWS accounts. So that's pretty much on the producer. Create, share, add objects, add consumers. Now on the consumer, I can do the same thing. I can see what data shares do I have access to. So here I got access to a share called sales share. So somebody gave me a new share access. So I can see that. And I can also look into see what objects that are there in the share. And this share is an inbound share because I got it from somebody else. So I can explore the different objects that are available. So note here we are illustrating everything with like SQL, but the tools, many tools like dbeaver and Agility, they all integrate with data sharing. So you don't need to use SQL. You can directly do it from the user experience. So one aspect to mention is producer has control on the data set. So for example, I want to remove a table from the data share. So previously I added a table called product subcategory, and I'm executing a command to remove the table from the share. So now I go to the consumer cluster, and when you rerun this command that shows me the objects inside the share, previously I had the product subcategory table. So now if I go and rerun the same command here, I don't see the product subcategory anymore. So essentially the moment producer removes a table from the share, revokes access, essentially that data set is not visible for the consumer anymore. Now let's go and add that table back. Another scenario that I want to demonstrate is if you're trying to revoke usage on the data share to a cluster. So previously I gave access, now I don't want to give access to that cluster anymore, so I can revoke access. Now when I go back to the consumer and query, try to list all my data shares, I don't even see that share anymore because the producer has revoked access. So the key point is producer retains control on the data sharing. So now let's go back and add the cluster because we want to demonstrate what happens on the consumer side workflow. So now we have seen the producer and how the producer retains control. And now on the consumer, in order to consume the data, it is pretty straightforward. So all they have to do is create a database. Here we are calling it consumer sales. But rather than creating it from scratch, you want to create it from the data share that you just got access to. So you say create database from data share. And once I create a database, I can give access on that database to my users and groups within my own consumer cluster. So now this AWS user got access to the data. So is a person in sales ops group. So the sales ops analyst would come in and they can start to see the shared data just like they would see the local data. So there are new set of metadata views, again visible as part of JDBC, ODBC drivers. So they can start to see not just the local databases like dev here, which is a local database, but they can also see the consumer sales, which is a database that is created from the data share that they have access to. So they can explore the databases, they can explore the shared schemas. So the schemas that are part of the data share. So here there are a few schemas in the consumer sales database. And you can also see kind of the different tables that are there in the data share. So essentially you can explore shared data just like local data from the BI and analytics as well as query tools. So now I'm trying to perform a query on the shared data set. So here in this scenario, I'm trying to see what are the total sales for a new helmet. It's a brand new product that has been introduced. And note that we are doing queries on the shared data here. Another scenario is I'm trying to understand the product sales by territory where there is no discount offered. So again, in this scenario, note that we are combining local data with shared data that is coming from another cluster. So the shared data has a three-part notation. So you say consumer sales dot producer sale table and a schema and the table name. So you use a three-part notation in order to refer to the shared data. So this is an example of a query which is combining data from the local cluster and the shared data. So this is kind of the power of the data sharing. No data transfers, no data movement involved, no copies involved, nothing, no ETL pipelines. We are just able to create a data share, and the sales ops cluster, the consumer cluster, immediately with no delays is able to access the data. So now on ongoing fashion, as more and more data is inserted into the producer cluster, the consumer cluster will be able to get immediate access to the data in a transactionally consistent fashion. So the data sharing setup is a one-time operation. It's not something you have to do again and again. Okay, so we have looked at what data sharing is, what problem it is trying to solve, what are the different use cases of data sharing, and how data sharing works end to end. We have a lot more information on data sharing, both sharing within an account and across accounts in a feature page that you can find, data sharing feature page on Redshift site. So you can explore more information. There are a lot more demos that illustrates different types of use cases. So that's something you can explore to learn more. In terms of the immediate kind of next steps to think about, if you have RA3 clusters, or you can set up RA3 clusters very quickly, you can start to share data within the same account. So this capability is available as GA. So if you have RA3 clusters, you can try it out, or you can set them up and try it out pretty quickly. So the second one is we have cross-account data sharing, so which is ability to share data across clusters that are in different AWS accounts. So you can try that as a preview. It is a public preview. It is available via a maintenance track called preview_2020. So you can set up a test cluster in that and choose that particular maintenance track, and you can try out even cross-account data sharing. If you have any questions while doing it, either on the capabilities or something's not working, or you're looking for ideas on what are the use cases in which data sharing can be beneficial, any questions, you can send an email to redshift-data sharing at amazon.com. And again, the feature page has a rich set of information, blogs, videos that you can explore to learn more about this functionality. That's all for me. Thank you. Thank you very much for listening.